Hello, everyone. How are you guys doing? Um, so what I have here is just the Unity Hub. That's basically I installed this onto Linux, and just so you know, I actually can run this whole thing on Linux. So once I already opened the Unity Hub, I actually can basically start a new project, and I'm gonna go to 2D for now because we're gonna be start by making a 2D platformer. I can name this like my first project if I want to. Let's say my first project. And wait, what's going on here? Oh, there it is. And then I'm going to create the project. So I have to admit, the reason I'm sharing the entire screen is because this window, the Unity Hub window just closed in my OS system. So now it's opening a whole new system right altogether. This game, I had to warn you, the game engine itself is pretty heavy. So it's going to take a while for the game engine to load everything. So uh, yeah, so while it's compiling scripts, it should be almost done, creating domain and opening project. Is it gonna open the project? There we go. We just opened our first project. So we're gonna click our mouse onto the projects tab window. I'm gonna expand this a little bit just so I can see everything. What I'm gonna do is this, I'm gonna right click this. I'm gonna create a new folder.
Wait, right click what?
I'm gonna right click onto assets, and then I'm gonna create a new folder. I'm gonna rename this folder scripts, and I'm gonna right click this folder again because this folder, what I like about this is that it indicates that the folder is empty. I'm actually gonna create a 2D, I'm gonna create a C# script, and I'm gonna play this. I'm gonna call this the player controller script. Player controller. And basically, this is essentially, if you look at where my cursor is, this is essentially what the code looks like right now. I'm gonna go to preferences. I'm gonna open now the way to go to preferences is that you go to the editors tab, you scroll down to the preferences window. So once the preferences window is open, you get to choose whatever IDE you're gonna write your C# code in. In this case, I'm choosing Writer EPE, but if you're using Windows, the most popular option would usually be Microsoft Visual Studio Community. You would want to make sure that you already have that installed. Otherwise, there's another way to open a C# script. You could actually edit a C# script with pretty much any text editor you want, and that will still compile with the Unity project. Do you have a question?
Can you use VS Code?
Yes, you can. You're gonna have to plug in a few things in order to have it run on VS Code. Otherwise, it's really not necessary to use an IDE. If you just have VS Code and you can't run the C# in there, it's still going to compile into the Unity engine itself. Yeah. So once I have that set up, I'm going to right click on a sample scene right here. This is actually the object hierarchy window on where the cursor is pointing at. So what we're looking at right now is pretty much the scene that we're actually editing our game in. This is where we actually test all the assets that we created into Unity. So all we can see now is just the main camera. What I'm actually gonna do is right click onto the hierarchy window. I'm actually gonna create a 2D object sprite, and I'm gonna insert a square into the scene. Now, as I zoom in here, I'm gonna use this basically as a platform. Now, we're just gonna change the color a little bit, maybe turn it red, but this is not necessary, by the way. I just want to be able to distinguish platforms that we see fit right here. I'm also gonna resize this a little bit. Hi guys, welcome to the club. And I'm gonna create my first my first platform. And what I can do is I actually can, let's say, before I duplicate this, I actually want to add some components in here. I first want to add just the box collider 2D. That actually allows us to input physics collision effects onto the specific platform. So once I already did that, I'm going to duplicate this right now. Let's see. Can I so I want you to press Control D to all together. just once. And then we're gonna drag this platform. Wait, what just happened? Let me do that again. I'm going to Control D, camera. I'm gonna do Control D, and basically I just duplicated the platform. So I'm gonna drag one platform away. I basically just duplicated this, essentially speaking. For this one, I'm actually going to resize this a little just to make it a lot longer. So if I zoom out a little bit, I'm gonna be increasing the size of the base platform. So that way we have a lot more room to test our player controller. As for this square, I'm gonna continue duplicating this a few more times. I'm gonna Control D, right here, Control D here, and then Control D in, let's say, right over here. And basically now this is basically your first platform. Now I'm gonna right click this again, and I'm gonna insert another sprite, a 2D object, and I think I'm gonna create a capsule. Now I'm gonna drag this capsule up just a little bit, and then I'm probably gonna change this color a little to orange. And again, this is only cosmetic. This is not necessary. This will not change the functionality of your whole project. And then now for the capsule, I'm gonna rename it player capsule, just so I can identify the object I'm interacting with. Now, as for the squares, there's one other thing I actually forgot to do. I'm gonna be holding the control button, and I'm gonna be clicking each of these squares, each of these platforms. And what I want to do is I want to create a layer called ground. And this is going to be important for what we're about to do later. So I'm going to insert ground. And then I'm going to go back to the player controller. What I want to do now is I'm going to insert, I'm also going to insert a collider, but in this case, I'm going to insert the capsule collider 2D. And I'm going to add another component called the rigid body 2D. Now, the reason why the rigid body is going to be important is that that is what allows us to input actual physical interactions with the player itself. So if I add the rigid body 2D, I'm actually going to make the character fall. So watch very closely. Let's see, it's compiling. You have a question?
Yeah, so when you're setting up the rigid body, is it already preset for them to have gravity to fall, or
Yeah.
is it
It just fell.
I mean,
It just
it's
fell.
like a property of the rigid body, or is it
That is the property of the rigid body. Let's say if you like imagine what would happen if everything's a rigid body all of a sudden. Everything's in free fall, so you cannot even tell if you're falling. You're basically simulating gravity. So
okay.
yeah. Basically simulating gravity. Yeah, but there's one other thing. There's actually one other thing that I would like you to do, but that's something I would like you to find out later. For now, I'm actually going to insert another. I'm actually going to be inserting our first C# script because basically we already have the collider. We already have the controller. Now, I'm actually going to be clicking on this script right here. I'm going to click on the player. I'm going to drag this onto, well, actually, first of all, I'm going to scroll down here. I'm going to drag the C# script onto the player itself. So we now essentially have like a player controller script. So I'm going to right click and open this real fast. And now, once I trust and open this, it's going to open a new window. This is actually our C# script in an IDE. We just basically opened the IDE, which we're going to be using to edit the C# script. The first thing we're actually going to be doing is we're going to declare some variables here. What did I just do? Oh shit! Sorry about that. Let's see. So I'm actually going to be declaring a few variables here, but I'm also going to open this new text, which no one else created. What I'm essentially going to do is I'm going to declare some movement variables. And I'm going to be Control V right here. This is something, if you write it down real quick, this header, this first line is basically going to be a header. So like basically if you go back to the Unity IDE, you're gonna see the inspector change a little bit. That's gonna allow you to sort of label and categorize and sort of organize these individual characteristics of your player controller. Um, um, so this is just for organization purposes. We have a header up here. Our first variable, which we're going to declare, is the maximum run speed, which we're going to set to 16. This is basically serialized, so I actually can edit this onto the Unity editor without having to open this IDE. The next variable I declared is actually a vector. So the 2D vector essentially has two components, the horizontal component and the vertical component. I'm gonna label it as like move input. The next two variables are actually booleans. So what I actually did here isn't really necessary. So I'm gonna organize this a little bit just for the sake of organization. I'm also gonna name this a private Boolean called facing right. So what these two Booleans are essentially doing is it actually sets the condition. It determines whether or not we are in the condition to move or to face the direction right. Now the last variable that we're actually going to be declaring is an integer called facing direction. That's essentially what will help us determine whether or not the character is facing left or right. Now we go to after we basically make the declarations, we're going to try and create our first few functions. Going back to my text editor, what we're actually there's one other thing. There's actually a few other things that we're going to have to declare, but for now, in our start function, we're going to write this line in like the starting function called rigid body 2D. Although the problem is we haven't created RB just yet. So to correct this, going back to my text editor script, we're gonna declare another variable called the rigid body. What this is going to, sorry about that. What this is going to allow you to do is you're basically declaring the rigid body 2D, and we're basically going to be inserting the actual rigid body as a parameter to the function itself. So this function, the component rigid body 2D, is already built into the engine. And this is essentially what we're going to be using to apply the rigid body physics onto the player controller. So we're gonna save the script for now, and we're gonna go back to the Unity. And now Unity is actually going to compile this newly edited script. So if we go back to the player controller script, we notice that our changes have already been applied. So we basically compiled our C# script onto the Unity engine. What we're actually going to do now is we actually have the rigid body. So the rigid body by default is already being applied to the player controller itself. So that's the reason why this thing actually still falls. So by default, the rigid body is already essentially allowing us to cause the player to fall onto the ground. But in some cases, you may include a line of code that requires you to drag and drop the rigid body. Otherwise, the player is not going to fall at all. But we're not going to do this for today. So we're going to go back to the IDE, and we're going to be adding a whole new, another set of variables. We're going to actually insert the jump. We're actually going to insert the jump variables into Unity by writing these new declarations. So if I enter this, I'm going to paste this a moment. So we essentially created variables for the jumping mechanic. But what we just declared is the layer mask, which I determined on what conditions are we actually going to be jumping from the ground. So what the layer mask is going to do is it's going to determine if the player controller is actually touching the ground. So only if it touches the ground, the player is actually going to be jumping. This is going to be important because without the layer mask, the player can pretty much just jump whenever it wants to. But we want to make sure we use a layer mask so that we set the player to jump only when it's on the ground. So in order to implement the layer mask, we actually need a physical transform called ground check. And this is pretty much because it's a serialized field, we're going to pretty soon create another object back on Unity. So if we go back to Unity, we're gonna right click on the player controller capsule again. And we are going to create an empty object, and we're gonna name it ground check. So, and then we're gonna like basically click on the player controller again. And if we look at the script real quickly, we notice ground check has been like now the variable has been taken into account. So what we want to do now, since we now have a layer mask, what is ground, we're gonna click on what is ground, and then we're gonna choose the layer that we just created called ground. Afterwards, we're going to drag and drop the transform that we just attached onto the player. We're gonna click on the ground. Well, actually, first we click on the player. We're gonna click on the ground, and we're gonna drag it. We're gonna drag this into. Actually, before I drag this real quick, let me do this. Let me scroll down the interface real quickly. So right here, I want to drag the ground check right over here over to the parameter of ground check. So that basically allows me to apply the ground check onto the player itself. Now that we have the ground check, I actually want to label this so that we know where the ground check is located. It's basically labeled red. So if I zoom in a little bit, we notice the ground check is located at the center of the player controller. I want to drag this ground check down to right to the feet. And this is where this is how we're gonna allow the player to detect what's on the ground. Just by placing the ground check transform right below the feet right here. So after that, we're actually going to go back to the Unity script, and we are going to we pretty much add these things right here. We're now going to add 4 new functions into the update function. Now, what the update function essentially does is this function actually gets called once per frame. So think of it as sort of like your main function that's going to execute the other functions that you're going to declare right here. We're actually first going to instantiate these functions. We're going to have these functions that we're about to paste called into the update function. So our first function is going to be check inputs. Second function is going to be check surroundings. Third is going to be run, and the other is going to be the flip controller function. To implement these functions, so we're going to implement our first function called check input. And if I enter over here, now this is basically how we declare the functions that we're gonna use to like sort of like dictate the check inputs. So within the check input function, you notice that the first line we're using this vector variable. We're using the x component of the vector variable to determine if the horizontal inputs have been entered. This function basically allows you to determine if the player is actually pressing any button inputs. For the first line, this first line essentially allows you to determine if the player is moving left or right. So like we're actually assigning the move input x variable to this function called input.getAxisRaw with horizontal as the parameter. So what this allows you to do is by default, what Unity allows you to do is write this string horizontal as a parameter, and Unity basically maps the string horizontal into a specific button inputs that allows the player to move left and right. The buttons that are being pressed could be the regular arrow keys, and it could also be the A and D keys. So if you press either of these 4 buttons, you're essentially causing the player to move left and right. But this would not happen unless you actually write the script right here. The other line basically allows you to do the up and down inputs. So get move input.y allows you to move the player up and down whenever you're pressing the W key and the S key. but these alone doesn't necessarily guarantee that your player is going to move. These are simply part of the process of implementing the ability of having the player control like the character left and right. The last one is going to determine whether or not the jump button has been pressed. So if the jump button is pressed, which we assigned here, the input dot get input down, uh, we essentially are going to call the jump function. So this input specifically is already mapped to the spacebar by default. So if the player presses the spacebar, it's going to call the jump function, causing the player to go up. And that's something we're going to be, and so now we're going to be implementing the next few functions down here in the update function. We're now going to implement the check surroundings function right over here. Yeah. And so if I paste this right here, this function basically this is going to be relatively simple because this function allows the player to check its surroundings to determine if it's in the right conditions to do certain things. So if the player is the first line reads that if the player is grounded, which is one of the Boolean variables we just declared up here. Yeah, right up here is we just declared the is grounded Boolean variable. So like if grounded is true, basically this function is actually a lot simpler than I anticipated. So there's not a lot I have to articulate. You're basically assigning this Boolean variable to whether or not the physics object is actually interacting with the ground or not. This whole line of code doesn't really work if the layer mask or the ground check transform has not been specified. So I'm not really going to get into more details on what this specifically does, but I want to let you know that this is a line that you're going to be using to check whether or not the player is on the ground, so that the player is able to move on the ground left and right, or is able to jump left and right. The next function now is going to be the run function, and that allows the player to move horizontally. We're to copy and paste. We're just going to copy and paste right here. But you know what? Before I do that, I want to actually go back to the main Unity editor itself and see essentially what we just did. So first, we want to save this code, and then we're going to go back to Unity. So what we just did right here, look at how we're going to take a look and see if all the changes to our code has been compiled and applied to Unity right now. We go back to the player controller, and what I want to do now is I want to see, actually, 2 people has entered the waiting room. I want to actually press the play button, see what happens now that the player has been. Uh-oh, we just got a compiler error. Huh, what just happened here? What just happened here? Wait a minute. Now my question is, how come my IDE is actually not detecting this right now? But
build like the code, compile the code in the editor.
let's try doing that. I actually want to build a solution. Wait a minute. Exception inside the handler. Type initialized. Type initialized. What just happened here? Would anyone like to tell me what just went wrong?
The type, what's the full error message? I think you did not initialize something. Oh, there you go.
Unhandled exception.
You didn't catch that. You'll need to add a error check.
System. That's weird. That is actually weird. Ooh.
You'll need to catch that error.
How do I cache it? Oh shit.
Try catch?
Try catch? I have an idea. I think I have an idea. You know what? I'm gonna brute force this whole thing right here.
Got it.
Yeah. You know what? I'm actually gonna drag this whole script and I'm just gonna paste it all into this editor right here. See. Let's see. I'm just gonna dump everything in here. I'll go over this. I'm sorry, you want me to build this again?
Yeah, build it again. Click on the hammer.
Build succeeded with warnings. Okay. Yeah. Okay. I'm gonna save the script for now. Let's see. Refreshing solution. What is it doing over here?
It's just reloading.
Okay. What happens if I press the play button? It's completing domain. Completing domain. There we go. Okay. That was annoying. For some reason, my IDE is not telling me what it's supposed to tell me right now. So this is really annoying. Let's see. I'm actually not able to. Oh, shoot. Yeah, look at that. So the player is moving, but the player is not jumping. So you notice what just happened here? I'm going to pause this right here. You notice that the player just actually tipped over. I'm actually going to fix this by going back to the rigid body 2D. This is something I actually want to talk about right now. So if you go to click on rigid body 2D, you go to you just click on constraints. You want to freeze the Z rotation. So if I play this again, that's going to stop the player from actually leaning over. So we're gonna do this again. I'm gonna do left and right. Okay, now it's looking better. There we go. So I'm able to move left and right now. But there's just one problem. I dragged and dropped the whole script right here, but it doesn't seem to be able to tell whether or not it's on the ground. So I'm gonna change that a little bit. Let's see. I'm gonna check the ground check a little. The gizmos looks fine. So this is what the gizmos is actually looking like. Like I already dragged the ground check right here. I'm gonna drag it a little bit lower to the feet. Click on the capsule controller again. And let's see. Let me test this real quick. I wanted to see if the controller is actually able to jump, but if I press the jump button, interesting. So now, so I'm able to make the character move, but for some reason the player is not able to jump right now. Interesting. What is happening here? So I'm gonna go back to the script and take a look at the jump function real quick. But I did notice there is no jump function. So there's so we're gonna take a look at the jump function real quick. What I do know is that this jump function, we only have an if statement right here. So the first line essentially determines whether or not the player is on the ground. And if the player is on the ground, when the function is called, the velocity we're basically assigning the rigid body velocity into a new two-dimensional velocity. That two-dimensional velocity will allow us to apply the jump force, the vertical force. So the horizontal component I'm highlighting here basically does nothing to the rigid body. So basically wherever the player is going to go, it's basically whenever I press the jump function, this function is not going to have an effect on the controller itself, like the horizontal movement. But pressing the button actually has an influence. It has an effect on the vertical velocity. So we're basically immediately changing the vertical velocity to go up. So the jump force that we just declared up here is like we assigned it to the number 12. So it's pressing the button causes the player to initially go up by 12 units. Like 12 units, that's the magnitude of the vertical velocity. But once the button is pressed, it's not going to continue going up. So, but now we're trying to figure out why else is the jump function not working. So there doesn't seem to be, so for now, I don't see anything wrong right here. We have the Boolean right here, and we assign the velocity to this new velocity function, which allows the player to go up. So we're checking to see there's nothing wrong with the jump force right here. But if we go back to the input function, if the input is if we're pressing the jump button, we should be able to call the jump function right here. So I'm gonna save this again just in case, but I'm not sure what is happening here. I'm not really sure what's happening here, but it might have to do with whether or not it's detecting the surroundings on the ground. This is interesting. I'm gonna go back to the IDE again, but feel free to ask me some questions at any moment, because right now I'm just basically trying to troubleshoot why the character is not able to go up.
Can hear jack shit, bro.
Horizontal movements have been applied.
You did not bind your key to the jump button?
I wonder if it has anything to do with whether or not I bind the key to the jump button. So far, I assigned it to ground, but let's see. Oh, wait a minute. I know what's happening. We're gonna have to. So once I click the square, I'm gonna hold the control button for a moment, and I'm gonna click each of these squares and change the default layer to ground. Because what happens is the layer mask is not detecting the ground, and that's because I did not assign these platforms as the ground. So once I already did that, I'm gonna do this again. And then so the player moves. I'm gonna press the jump button and see if it. Oh, there we go. There we go. So we essentially have. So now we essentially allow the player to jump, just because what we actually did is we actually changed the layer type to ground for each of these platforms right here. So what we're actually going to do next is, in order to determine how the player is interacting with the environment, we're going to create the face. I'm going to be right-clicking the player capsule. I'm going to create a new 2D object, and I'm going to insert the circle sprite. And now, just for organization's sake, I'm going to set the order in layer to 1, so that the circle is always appearing. I'm also going to change the color of the circle to like dark purple. That's good enough. Okay, so I'm also going to resize this, and essentially we are essentially having at least one eyeball right over here, and I'm gonna click on this move indicator, so the move tool that allows me to move the eyes wherever I want to. I'm gonna move it down a little bit. I'm gonna press Control D to duplicate the eye. So now we essentially have eyes right here. I'm going to create another sprite just for the fun of it, because we still have plenty of time. I'm going to try to create the mouth. I'm just going to resize the triangle just a little bit. And I'm also going to be rotating this a little by 180 degrees. Wait, what did I just do? 180 degrees. Wait. Oh, wrong variable. So I'm going to change this to 180 degrees. And then I'm going to change the color to dark red. And then I'm going to move this mouth just a little bit right below the eye. So there we go. There we go. Perfect. Take a look at this. We just essentially created the face for the character. And if we press the play button, I want to see if the player is able to flip left and right. Sweet. Oh, yes, that feels so good. Wait, what just happened? Wait a minute. The mouth. I gotta adjust the mouth. So I'm gonna click on the triangle. I'm actually gonna rename this the mouth. And I'm also gonna rename the other two guys, the circles, I'm gonna rename them the eye. Eye number 1 and eye number 2. And for the mouth, I'm gonna set the order to 1. And now I'm gonna press the play button again just to see if let's see. Okay, so now the mouth is not disappearing whenever I face the right direction. So that's good. Okay. So we essentially have to so essentially we allow the player to move. The player can jump now. And actually now I don't know where the player went. So all right. So I'm gonna have to fix this, but I don't know where the player went. And the other thing you may have noticed is that the camera is stationary. So we want to change this in such a way that we have the camera follow the player. The way we're going to do this is that we're going to open the window, and we are going to open the package manager, which allows us to insert functionalities into the Unity editor itself. So we're going to click on packages and open the Unity registry. We're going to search Sin Machine. And then we're going to install Sin Machine just for a brief moment. And by having this installed, that is going to allow us to create a 2D virtual camera. And that is going to, essentially, what it's going to do is it's going to overwrite the functionalities of the main camera such that the main camera is actually going to move along with the player. After we exit this, we're going to right-click I can minimize this for now, but we're going to right-click the hierarchy system, and we're going to scroll down the Sim Machine and create a 2-dimensional camera. And I'm going to name this player virtual camera, just so I know that this is assigned to the player. What I'm then gonna do is notice that it's actually waiting to see what transform it's gonna follow. I'm using the whole player capsule as a transform. I'm gonna hold the click and I'm gonna drag this player capsule as a transform to this tab right here. And this is going to cause the camera to always follow the player, essentially. I can also change the ortho size to about, like, let's say 22, so I can see everything. Let's see how big the camera is going to be. Actually, I'm going to shrink it down to 10. That's good enough. So now I'm going to press play. I'm going to press play, and there we go. So now the camera is actually following the player. Now, what happens if I press the jump? I want to know where the player went. I see what happened. So now I know where the player is. The thing is, the character is jumping way too high. So that's why I don't know where the character went. So that explains everything. That explains everything. Okay. You know what? I'm actually going to do this. What I'm going to do at the player controller script is I'm going to actually adjust the jump force to about like 6. So I'm going to half it, essentially. I'm going to press play again. And also notice what Unity allows you to do is that, so while the game scene is actually on play and you're able to test how the game is going to play, so while you're testing this game scene is still running, I actually can edit the variables on the fly. So if I want to add the jump force, change it to 22, it's going to change the jump force while the player controller scene is still on play. So if I press this button, I actually just immediately edited the jump force to 20. Now I edited it to 1. It's not going to do much. Yeah. So now I edited it back to 6. Player's going to keep jumping right here, but this thing is not going to be saved once I close the scene. So when I close the scene, the jump force is reverted back to 6. But if I open the scene again and I decide to change it while the scene is being played, Let's see. I want to change this to 22. I want to make this character jump like a superhero, but if I just press the sample scene, it's not going to save this. It's reverted the jump force back to number 6 because I just saved it into the main scene. What I'm going to do now is that I'm actually going to save the whole project. I'm going to save the project, and then I'm going to, you actually can press the Control and S keys because what you're merely doing is that you're just saving the whole scene. That allows you to continue to work with the way your project is right now. But so that pretty much like that's essentially how Unity works, and that's essentially how those are essentially like the tools that are already available to you when it comes to making a video game. Because a lot of the stuff that's pre-built, it's meant to even like before you even learn about how to program the controller with C# scripts, the whole editor itself provides just a user interface for you to figure out how you want to change the functionalities of your whole project. So there's not a lot you have to, I mean, there's a lot that you actually can do to change the functionality of the game without necessarily having to open the C# script. But opening the C# script basically allows you to add new functionalities to the player controller itself. So what I just copy and paste here, which I did out of desperation because I want to troubleshoot this project right off the bat, is I want to continue from where I left off in the C# script. Did someone say brownies? Oh, wow. Okay. So the next function I want to cover is basically the run function. So the reason why the character is able to move left and right is because we have an if statement that determines whether or not the horizontal move input is equal to 0. That is determined by whether or not the button inputs are pressed. So because we assigned the move input horizontal variable to get access raw horizontal, like we essentially assigned the move input. Wait, did someone announce we're having brownies right now?
Oh, yeah, did you want some? I'll get you one. There's
Well,
like this much of brownie.
we'll do this after we finish the workshop.
Yeah.
Hard.
No, don't have the
Rocks.
brownie.
Hard brownies? Rocks with no flavor? Okay, I'll find that out. I'll find out myself once I'm ready. So where was I? I was actually going over the move input, right? So the only reason that the run function is able to work is because we essentially assign the move input X variable to whether or not we want to determine whether or not the movement input has been assigned to 0. So if it's not equal to 0, just because we press the left and right button keys, so if we press the horizontal movement keys, this variable right here is not going to be assigned to 0. So once that happens and we meet this condition of the X input not equal to 0, we set the rigid body velocity of the character to a new vector that basically causes the horizontal movement of the player. So we actually multiply the maximum run speed of the player controller with the movement input. So the movement input dot X is either going to be 1 or -1, depending on the buttons you're pressing. So whatever buttons you're pressing, we're basically multiplying this variable with the maximum run speed. So imagine what happens if I don't actually have this right here. If I just erase this and I save the script, which I don't necessarily want to do in an actual project, I'm going to have this compiled into the main scene. And watch what happens when I remove this part. So once I play the scene, whenever I press the left button, this player is going to continue moving right. You notice what's wrong here? This player is still moving in this direction and there's nothing I can do about it. Now, why did this happen? because what I actually did right here, I actually removed this multiplier. I actually removed this factor, move input dot x, which determines which buttons I'm pressing. And because this player controller cannot determine what buttons I'm pressing, it's gonna keep moving right no matter what. So even if the player is now facing the other direction, it's gonna keep moving in the right direction just because I remove this horizontal input that is determined by whether or not the player is pressing left or right keys. But for the vertical component, nothing really happens because I set the rigid body just to the default y velocity. So this has no effect to where the player is going, whether the player is going up and down. Only the jump function is causing this effect. So we move on to the next function. This flip controller is what allows the player to turn left and right. So let's see, let's actually see what happens if I actually cancel out the flip function. I'm going to comment it out by double dash. And I'm going to exit. I'm actually going to go back to the Unity editor. And it's going to be compiling the domain right here. So if I zoom in and I press the play button, So the player is still going to be able to move left and right, but watch what happens. The player is not flipping. And that is because I actually removed the function call for flip controller. So if I want to call the flip controller function, I have to leave it like this, and not have to comment it out. So without this function right here, the player essentially cannot flip left and right. Basically, this is the only animation you're ever going to learn in this workshop. So you're like, there's actually an animation controller in Unity, but that's not something I want to cover right now since we're very, very short on time. But the reason why we're able to flip the character is because we have this if statement, which has more than one logical predicate. So the logic predicate, well, actually, we have 4 logical predicates right here. For the first logical predicate here, we want to determine whether or not the player is actually facing right using this variable, the Boolean variable, facing right. We also set the and condition and want to determine whether or not the horizontal input is greater than 0. In the other one, it's actually the exact opposite. Basically, for this side right here, it's determining whether or not it sets a condition for whether the player is actually facing left and the movement input is actually in the left direction. The other condition is whether or not the player is facing right. And if you're pressing buttons that is causing the player to move in the rightward direction, then if either of these conditions are met and the player is actually facing the opposite direction of the button inputs, this whole function is going to call the other function the flip function, which is actually a lot more simple than this whole function altogether. In the flip function, whenever this flip function is called, it actually switches the orientation of the face direction. It switches the value of this integer by a factor of -1. So every time it's switching the face direction, you're actually multiplying this by -1 such that the facing direction is actually it actually has been reversed. It's been inversed. So in short, we call this inversion. We are inverting the facing direction of the player controller. In the next line of code, we're actually setting the Boolean to the opposite. We're setting if this Boolean facing right is set to true initially, we actually are going to be switching the value to false. We're actually going to falsify whether or not the player is actually facing right and vice versa. The last line of code is actually what causes the whole transform to occur. So what this function allows you to do is actually rotating this JPEG. So what the sprite really is, it's actually just a JPEG moving into the sample scene. What this function does is it's rotating the image 180 degrees entirely. Once it flips it over, it basically flips the character in the mirroring direction. That's essentially what the transform is doing. It's basically flipping basically flipping the player controller just by 180 degrees. That's pretty much the only animation that's being implemented right here. So that's what allows you to see whether or not the player controller is actually moving or not. This other one which we already covered because I wanted to troubleshoot the problem is the jump function. We essentially, as I mentioned earlier, this jump function only works, it only moves up if the player is actually grounded. And whenever this jump function, like whenever this jump function is being called, it's being called only because we press the movement input jump. And this jump input as a string, because we have the string right here, we basically, Unity just maps the string to whatever buttons you're pressing. So the string that it's been assigned to is actually the space bar by default. So no other button is going to work that's going to allow the player to jump. Only the jump function, only the space bar will allow the player to jump. And you'll have to edit, if you want to change what buttons you want it to be mapped to, you're actually going to have to go back to the Unity editor and change what kind of button keys you want the jump button to be assigned to. With that being said, we're gonna talk about the last function for about 4 minutes. We're gonna spend the last 4 minutes talking about the gizmos function. This function is not really necessary for you to edit the project, but this essentially allows you to see how big the transform is. So if we go back to the Unity editor and we press the player capsule script, we're gonna press the ground check button right here. We notice that the ground check, we place the ground check exactly right below the character. We're actually going to remove this label. So now you cannot really see what the gizmos look like unless you just press the player capsule. So when you place the player capsule, you essentially are now able to see what the gizmos is looking like. Without this gizmos, you can't really see how big your ground check is. And you can't even determine whether or not the ground check actually exists in the player controller. This transform is what allows the player to detect whether or not you are on the ground. The layer mask actually identifies what is the ground. It's used to identify which object you're interacting with is actually considered ground. So if none of the objects are actually the ground, as I mentioned earlier, the player is never going to jump at all. Even if it's on a platform, the player would not jump because you did not label the platforms as ground. The platforms is just labeled as default. So then the transform doesn't really know what it's interacting with. With that being said, this is essentially like if we just place this again, completing the domain. Unity is actually kind of heavy, by the way. We essentially everything we have right here pretty much works the way we expect it to. We have the player move left and right. The player is able to flip over. We press the space bar, the player can actually jump. And all the platforms you're interacting with is actually not allowing the player to move in some way because you now have the box collider. So essentially, this is not a game just yet, but you essentially just created a base for your first project. Like, essentially, you practically just made a video game, but this is not the final product that most people are going to be shipping, but this is essentially how Unity works, like, from the get-go. With that being said, what we just covered essentially is just sort of an overview of what you can do with the game engine. So we're not really going more in depth with Unity, but what the main purpose of the workshop is to basically be a complete rundown and an overview of what you can do with Unity, with the game engine itself. So I want you guys to get at least a superficial understanding of the tools that you have available just to make your first project. With that being said, this tutorial alone isn't going to help you learn how to make an entire project, but this tutorial, at least now, with this tutorial now, you're now at least familiar with what solutions you already have built for you that you could put together to essentially create a working project. So with that being said, that's pretty much all I have to cover for now. But if you guys have any questions, feel free to let me know.